Hello everyone, I'm Nicolas, a researcher at the Center for Energy Informatics at the University of Southern Denmark. And for the publication this week of an article we wrote for the Journal of Applied Energy, I thought I'd try something new and do a little video abstract of the paper that will hopefully give you an idea of what the paper is about in general. And if you're interested, you're more than welcome to follow the link provided with this video, where you have access to the journal, which should be open access. So, the title of this paper is Process to Market Matrix Mapping, a multi-criteria evaluation framework for industrial processes, electricity market participation feasibility. Now that's quite a long title, so I thought I'd deconstruct that into its main keywords to give you an idea of what the paper is about. So the first kind of concept is industrial processes. So this focus on industrial processes implies large electricity consumers that have kind of a high incentive to reduce the electricity bill. But the way we're going to do so is not through reducing their overall consumption. I guess that would be more about electricity efficiency. What we're going to focus on is more about electricity flexibility, so more when you consume. And the incentive to do so is provided by the second keyword, which is electricity participation, electricity market participation. Because essentially, in a liberalized market, market prices should reflect the kind of state of stress of the overall electricity system. So essentially incentivizing consumers to adapt their consumption based on the market prices. So the problem is, at the moment, this is not how electricity markets work. Unfortunately, most of the demand remains inflexible, which means that it's up to the generation mix to adapt to it, which explains those very high spikes in prices when, for example, very expensive gas power plants need to be put online to react to these consumption peaks. So in general, we would like consumers to be more active market participants. And so far, I've talked about the electricity market in a singular term, but what's important to realize is that it actually is composed of a series of electricity market options that operate sequentially from the initial kind of load scheduling time all the way down to dispatch time. And so each of these market options provide a different service to the grid, and therefore have different participation requirements, how quickly you need to be able to dispatch your load and for how long time. Now that, of course, will be difficult for industrial consumers to assess which market option is most suited to their specific industrial process, right? Because we talk about industrial consumers in general, but it's also important to realize that they are a very heterogeneous group with very different properties. For example, a cooling process might be able to shift its temperature up or down in a kind of continuous way, while a cement milling process has these fixed time batch processes, which it can, however, reschedule throughout the day if it makes economic sense to do so. So there's different types of processes and different types of markets out there. So the question is, in which market options can a specific given process participate? So and this is important to remember, because this paper is about participation feasibility, not necessarily whether you should participate, whether it makes financial sense from an economic perspective. This has been studied kind of extensively in the literature, but we're kind of taking a first step back before that, and we're actually looking at whether you can, both from a technical perspective on the consumer side and from a regulatory perspective on the market side, whether this kind of combination actually is technically feasible. So this is kind of the question we're trying to answer, and to do so, we are providing this matrix mapping approach, where essentially a set of parameters from the consumer side are compared to a set of parameters from the market side. Now these parameters are kind of generalizable. So the consumer flexibility properties has been divided up into a series of 12 parameters, while the market properties are divided into a series of 9 parameters. And these 12 consumer parameters are grouped into 3 subgroups. So load-based flexibility, how much you can shift, for example, up or down. The time-based flexibility, so for how long you can shift, how quickly you can do so, and how often, for example. And then organizational-based flexibility. So that's less about the physical shifting of energy in time, but it's more about when are you scheduling your load processes, your load schedules. What are your operational times? When are your facility opening times? Or how often do you measure your loads? And all of these parameters will actually influence your capability to participate in the market eventually. And so on the market requirements side, there's 2 categories. There's the bidding requirements on one side. So how long in advance do you have to bid, or how much is the minimum bid size? And on the activation side, it's more about how quickly should you be able to provide the service required of you, and for how long, kind of the minimum duration. And so once we have these parameters on both the consumer and the market side, we can kind of start to compare them one by one. And this is where the matrix mapping comes into play. And whether these requirements are met or not, then provides a certain score to each of the parameters considered. And so eventually we are left with both flexibility parameter scores for the consumer, and then market parameter scores for the considered market option. And so in the end, this is both useful for the consumer because it allows him to decide which market participation option is most feasible, which has lowest barriers essentially to market entry based on the obtained score. And from the regulatory, or for the policymaker or market regulator side, it's also relevant because it allows them to see which market parameters score lowest and are therefore presenting the highest barriers for consumers to enter that market. And so essentially through this parameterization, both of the consumer side domain and the market side domain, we really tried to give a generalizable approach that's applicable to a wide variety of industrial processes, but also a wide variety of market options, as market regulations also change through time, and depending on the market context you're considering, you're faced with different market options. So I hope this approach was interesting, if not useful to you. And as I said, you're more than welcome to actually refer to the link below to get a lot more detailed information on that. That's it for me for now. Thank you very much for your attention.